Okay, so this is just a review of exponentials. See, this is an exponential, and then I moved it. And that 3 that I added to the inside with the x, I'm going to put a little blue parenthesis here. You don't have to have that parenthesis, but it kind of reminds me that it's up in the exponent. That moved it 3 to the left. All right, so then my points I actually get are -3 goes in, and I get a 0 power. Anything to the 0 power is 1. I know somebody just got that wrong. It's normal because to the 0 power, people think sometimes that that's just gets a 0 answer. No, to the 0 power is 1. Okay, the next one is a -2. A -2 goes in here. And then all of a sudden the 3 and the -2 makes 1. 2 to the 1 is 2. And then I wanted to show you a positive number, at least one normal number here. We put in 1. And then 1 plus 3 is 2 to the 4th. That's kind of gross, but you can do it. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now you may recall that I said that if you went just off the graph and you labeled it, 1 comma 16 might be way up here as long as it's reasonable. I'm going to be the judge of what's reasonable. You try to label 1 comma 50 way off the graph, I'm going to say no, you went too far off the graph. But if you're just off the graph, the graph paper is only going to go to 10. I would have probably taken this one because it was a little bit far off the graph, but far enough you could probably still put a dot in an appropriate spot and label it. All right, but otherwise you really want these points to be on the graph. One more thing, and this is important. The asymptote starts here at 0, and you ask yourself, did this move up? It did not. So the asymptote is still right there. If there was an up number like out here, like if there had been like a +5, then the whole thing would have moved up 5 and the asymptote would be up 5. The asymptote for this thing is whatever's outside. So the asymptote for this thing, this line that goes like this, right there, it never moved, so it's still on the x-axis, which is y equals 0. Y equals 0 is the asymptote. Now ask yourself, would you ever remember the asymptote? If you're the type of kid who forgets the asymptote, then maybe you should just write it right in your chart. Asymptote is at y equals 0 because you got to have the asymptote or you won't get the points. I know you guys. I know I'm going to see a ton of kids. This will be the question on the test. And they will have the dots in there, but they won't have the asymptote. In this case, the asymptote moved down 1, and so it's y equals -1, and should be an asymptote right there. Okay, let's actually get the accurate points for this graph. I already told you where the asymptote is. Would you please find me 3 accurate points? The beautiful thing is that today, oh man, Liam, you gotta write an email. Put that in your backpack. Get your iPad. It isn't even on. That's frustrating. Waste my time, waste your time. Half the problem off the word. Okay, so I hope you picked some points like, I'm going to put in 0 because I said to make it small. And 0 in this case makes it very small. 3 to the 0 is 1, but don't forget the -1 out here. 1 minus 1 makes 0. So 0, 0 was one of the points. All right, next I'm going to put in 1 because that's still going to keep it pretty small. 3 to the 1 is 3, and then 3 minus the 1 is 2. And if I put in 2, that's 3 squared is 9, minus the 1 is 8. I put in 2, I got 8. Is that 3 points? Yep. They're all numbers that are less than 10, so they would all graphed. And it looks kind of like that.
How'd you get 8?
I stuck a 2 in for x, so I just put a 2 there. Would you agree that's 3 squared, which is 9? A lot of people go 3 times 2 is 6. 3 squared.
Yeah.
Okay. 9 minus 1 is 8. Thanks for asking them. You do catch me on mistakes. This time I was right. Okay. So, what's different for today? Only a negative. Just a negative. Try this one. Negative, parentheses. I encourage you to use these parentheses. It makes a difference. 2 to the x minus 1. Now, why would that negative there change the answer? Well, because it doesn't reflect. The graph should be different if it gets reflected. That's what negatives do. They're a vertical reflect. You know that from your last test. So let's not even talk about what the graph would look like. I mean, generally they look like this, but a reflection, I don't even care right this second what that does to the graph, what that looks like. All I care is that I do my points right. Because if you do your points right, they'll be in the right spot. So let's make an XY chart. Be careful and to include that negative. You can pick any numbers you want. Just be smart about it. Don't pick like 17 for X. Find 3 points.
I need to do this problem.
Okay. Oh. Okay, I'm going to pick 0, and I'm going to realize I don't really like it because I have to do 2 to the negative 1. Now, if you know how to do it, it's not that bad. 2 to the negative 1 is a half. It takes this number and it flips it. But I would just recognize that 0 is not a great easy point, and I just would then not choose it. Now, I'm going to show you the actual answer, but you could just reject it if you want. Find other points. All right, so if I put in 0, that's 2 to the negative 1, and 2 to the negative 1 is 1/2. And then it's negative, so it'd be negative 1/2. It's doable, but you don't have to pick it. Pick something you like 1. 1 is super easy. Because then you got to the 0 power, which is 1, and then it's negative 1. You just got to show me the hub pass that you made.
Sorry.
That's all right. So the next one is 2. I want to put in a 2. And then it's 2 to the 1, which is 2, and then negative 2. Super, thank you. All right. There's 3 points. Did you remember the asymptote? Let's actually graph this thing. Just don't forget the asymptote. Graph those 3 points. We don't need hyper accuracy right now. If I did, I'd have you take out graph paper, but we don't have to have accuracy. You could on purpose add graph paper in if it was annoying you that you weren't being super accurate. Graph paper's fine. It's better than just sketches, but I don't need that right now. This is good enough. Now, the asymptote starts here. Did it move? No. So it's still there. So then my final graph just goes through those points and gets closer to the asymptote, but it's like an electric fence. You don't want to touch it. My mom actually told me a story about a time she encountered an electric fence for the first time. She lived in Wisconsin, and she was walking across this field that she didn't realize had not just a cow, but a bull in the field. And so she, all of a sudden, the bull is like running up, and it's gonna like knock her over. It's gonna butt her with its head. And she starts running for the fence because she was pretty close to the fence to get over the fence. And she grabbed the top of the fence to like try to get over it, and she didn't realize it was an electric fence. And it doesn't just, you don't just like stand there and get electrocuted. It's got this, it's got this pulse that goes through the electric fence. It doesn't stay continuously on, because if it did, it would electrocute you. So it turns on, off, on, off, on, off. So when she grabbed the fence, it turned on, and then the crazy part is, when you're getting electrocuted, you can't let go of whatever you're holding on to. Ironically, my mom and my dad both experienced electrocution at one point in their life. My mom was at this moment. She grabs the top of the fence. It makes her hands lock onto the fence, and then she flips over the fence with her hands locked onto the fence, and then it lets go of the electrical pulse, and then she's able to let go with her hands, and then she like flies off of it on the other side. But she didn't get hit by the bull, at least. So anyway, that was her electric fence story. And why? Because, why am I talking about it? Because electric fence, a lot of us teachers actually use this like an electric fence. It's like a fence, and you don't want to touch it. My dad's electrocution story was, he had a drill that was a kind of plug-in drill. You know, nowadays a lot of our drills are not plugged in. They're like cordless. But he had a corded drill, and there was a short in the drill. He didn't know. And so when he pulled the trigger on the drill, it started electrocuting him. And the electricity was flowing through the drill, from the wall, into the drill, into his arm. And the crazy part is he couldn't let go. And he knew he was being electrocuted, and he knew that he wasn't going to be able to let go, because he was a shop teacher, and he knew that this is how this worked. And so he was able to like just shuffle and swing his arm enough until it finally broke the plug pulled out of the wall. And then when the plug pulled out of the wall, he instantly could let it go. And so the drill flew across the home and broke a mirror that he had sitting like off to the side. So anyway, but if he hadn't known about that, if he just stood there going like, I can't let go, he would have died from being electrocuted. So if this ever happens to you, where you grab onto something and you're like, I can't let go of this thing, you have to like move in such a way with like your legs, you won't be able to let go with your hand, so that you can hopefully unplug this thing. Or maybe somebody can help you to get it unplugged. All right, so anyway, electric fence story. There is your graph. You know, they originally looked like this. What happened? It got reflected, see? All right. So today is actually just wonderfully simple. You just have a negative to deal with every now and then. This one's going to be up in the X area. I'm going to put a negative right there. 3 to the negative X. All right. Make an XY chart. Find me 3 points. Hint, I would hit negative numbers. Because if you put a negative number in something that's already negative, it'll just turn back to positive. Like stick -1 in there, and now it's negative of -1, which is really 3 to the 1, which is really 3. Hunter, what's another number that would work nice and isn't negative? 1 would work nice. Why does that work nice for you? Like, because you know how to do it, right? What if I put in 1? What do I get? Nope. Okay, if I'm going to put in a 1 right here, that's 3 to the -1. You guys need to learn that to the -1 power flips it, so it'll be 1/3. Okay? All right. But what I was really hoping you were going to say is something easy to put in that isn't negative. Somebody else have another guess? Easy to put in and it's not negative. Yes? He just put in 1. Something else that is easy to put in and is not negative. Yes? 0. That's what I was looking for. Because, you know, to the 0 power is actually pretty easy. Even the -0, which is just 0. It's just 1. There's 3 points. Now you might pick different ones. I totally guess you'd pick different ones. You probably pick -2, which you would then put in and you'd have negative of -2, which would be +2. 3 to the second is 9. But your other number might have gone too big. So, because 3 to the third is 27, and that's going to be way off the graph. I wouldn't have taken 3 comma 27. Okay. Did you remember the asymptote? Now, we didn't actually graph it, but the asymptote starts at y equals 0. Did it ever move? Then the asymptote would be at y equals 0. You don't have to put this here, but I'm warning you, a ton of kids forget that put the asymptote on the graph, so it might be really smart for you to put it in there, and it kind of locks in that, oh yeah, I got to put in the asymptote. There's nothing on the outside to move it, so the asymptote's still at 0. All right. One more. -4 to the x plus 1. If you can find 3 points, I know you can graph. If you couldn't graph by now, you would have failed this class. If you've forgotten, it's okay. I did actually have a kid this morning that was asking me, I forgot how to graph like -1 to 4 or whatever. It's okay to forget, but you know that you can graph points. The question is, can you find 3 points? Kai, give me a good number to put in. 0 is a good call. And then it becomes -4 to the 1, but this is important. This gets done first, and then you make your answer negative. In this case, it won't actually matter, but just so you know, because of the way I put the parentheses on there, you have to do the parentheses first, right? And that negative in front is the last thing you would do. So Kai, final answer, if you put in 0, you get? -4 is correct. What if I put in 1? Well, then I have a 1 here. 4 to the second, 16. Careful. It's not -4 times -4. That negative is last, so it's negative. 4 squared is 16. That got really big. Dang. Mr. Server might take that one, but I definitely is not going to take it if I put in a 2. Because then it's going to be 4 to the third is 64. Way off the graph. So you're going to have to go with -1. -1 goes in. You get to the 0 power. Cool. Anything to the 0 is 1. But the negative gets applied later. -1. If you thought that was 1, check yourself. You've got to do the negative last when it's like this. Okay. And then the asymptote. Y equals what? Y equals 0 is the asymptote. Hasn't moved. Nothing out here. Okay. All right. So now you have some graphs that have negatives in them. So it's just like yesterday. You just got to be more careful because there's a little negative usually in the exponent or maybe out in front. Yes. All right. So right now, would you please find the worksheet, open it up, and we'll have a bunch of work time. I'll tell you which ones to skip. Please upload or download, I think it is. Download the worksheet. Get it into something you can write on. Let me look at it with you. I'll figure out some that are appropriate to skip. And then maybe you just got a little smarter on how to do this. Maybe smarter than you were yesterday. Would you please take out the worksheet from yesterday, and then we're going to spend the rest of this hour. You can fix it. If you made mistakes on that, fix it now. If you aren't finished with it, fix it now. We're going to hand it in at the end of the hour. Please take out that worksheet. Sometimes the skips are different in different hours. In your class, it looks like I skipped 2A and 2C. Does that sound familiar? Okay. So anybody that needs one of these worksheets, I have extras. Okay, cool. All right, so just make sure that that gets done by the end of the hour. It's the same thing as this. It's just that worksheet didn't have any negatives squirreled away in the problems. On this new worksheet, let me look at it for a second and I'll try to figure out which ones to do and skip. Okay, this time we're going to skip 2. We're going to skip 1C and 2C. Skip problem 1C and 2C. So we'll do 1A first. You're skipping 1C and 2 part C. Would you read me number 1A?
F of x equals 2 to the negative x.
2 to the negative x. And they just want you to graph it?
Yeah.
Awesome. XY chart. So, let's get some points in here. Chase, would you give me a number to stick in? 2 to the negative 1. About half the class probably thinks that's negative 2. It is not. 2 to the negative 1 is actually, say it if you know it. 1/2 is correct. To the negative 1 power means you take this number and you flip it over, which since 2 really means 2 divided by 1, that's why when I say flip it over, it's 1/2. Okay. Another thing to put in is 0. Anything to the 0 power is 1. I think you're getting the idea. All right. Don't forget the asymptote as you graph this sucker. Has it been moved? No, there's nothing on the outside, so it hasn't been moved. It's still y equals 0, which is right across here. Don't forget that asymptote or you won't get the credit for the point. I know it's right on the line, but I'll be looking for it. You can usually tell even if it drew it right on the line. Make your 3 dots, make a little curve going through the 3 dots. If your 3 dots are an exact straight line, you did it wrong. Your 3 dots will be slightly off from straight, and that tells you which way the curve goes. All right, let's do one more. If I put in negative 1, it's going to work slick. Anytime there's a negative, you put in a negative, it turns positive. 2 to the positive 1, which is 2. Now I'm going to graph these 3 points. Negative 1, 2, 0, 1, 1, 1/2. I know those look pretty straight, but you know it's supposed to be a curve. There you go. Any questions on that? All right. I hope today locks in the graphing part, because then we have to move on from graphing to the other part of the test. Once again, I would picture your test being not half graphing though, probably a little less. This next unit, there's some graphing, but it's probably not as big a deal as last unit. Because you're supposed to already know this stuff, it's just a different equation, and the rules for graphing are pretty much the same. All right. If you need help, I want to help. You just have to come up and ask. And that's all I got for you for today.